Dear students, in the previous lecture, I told you about direct proportion, and we did a few questions based on direct proportion. I told you if there are two quantities x and y, such that when x increases, y also increases, or when x decreases, y also decreases, then we call that x and y are in direct proportion. Okay, now today we'll begin with another example based on this direct proportion or variation, and then I'll explain about inverse proportion. So first of all, an example based on direct proportion. In a model of a ship, the mast is 9 centimeter high, while the mast in the actual ship is 12 meter high. If the length of the ship is 28 meter, how long is the model of the ship? How long Okay, now first of all, when we make a model of any structure, then there is a scale. Means if the length in the actual structure is say 10 meter, and we make it 1/10, and in the model we take it as 1 meter. In that case, if the height of the structure was in the actual structure it is 30 meter, then again 1/10, and it will be 3 meter in the model. That means any dimension, if the length of that if the length or the breadth or the height, if it increases in the actual structure, then that will increase in the model also. And if that dimension of the length or the breadth or the height decreases in the actual structure, then in the model also it will decrease. That means here you can see the length in the actual ship and length in the model, they are in direct proportion. When one increases, the other also increase. When the first decreases, then the other also decrease. So what we do, as the dimension in the actual ship and the same dimension in the model are in direct proportion, so now we'll make the table. Dimension in the actual ship, that is x, Now you can see it is given in the question that the in the model of the ship the mast is 9 centimeter high. So here you write down 9 centimeter. Whereas in the actual ship the same mast is 12 meter high. So you will write 1200 centimeter, because you know we have to make the unit same. So 1 meter is 100 centimeter. So 12 meter will be 1200 centimeter. Now the length of the actual ship is 28 meter. So you write down 2800 again in centimeter here. 28 meter means 280 centimeter. And now you have to find the length of the model. So you have to find this y1. Now I told you in the previous class, when two quantities are in direct proportion, then x1 upon y1 is equal to x2 upon y2. That means 1200 upon 9 is equal to 2800 upon y1. These two zeros we can cancel. 3 4s are 12, 3 3s are 9. Now you cross multiply. 4y1 is equal to 28 into 3. So y1 is equal to 28 into 3 upon 4. 21 centimeter is your answer. That means the length of the model will be 21 centimeter. Clear? The length of the model, when the length of the actual ship is 28 meter, then the length of the model will be 21 centimeter. Clear? Now, inverse proportion. Inverse proportion. Suppose there are two quantities x and y such that when x increases then y decreases, or when x decreases y increase, then we call that x and y are in inverse proportion. Clear? I repeat, if there are two quantities x and y such that when x increase then y decreases, and when x decrease then y increases, then we call that x and y are in inverse proportion. I'll give you an example. Suppose there is some construction work going on at your place. You are constructing a few rooms and all, and you have to employ a few laborers for that. So if you employ two laborers, then your this construction work will take more time. Now if you increase the number of laborers, say you make it 10, then automatically the days taken to complete the construction will be reduced. So here you can see, when we are increasing one thing, we are increasing the number of laborers, the days taken to complete that work is reduced. So they are in inverse proportion. Clear? Another example, suppose there is a car and the car has to cover a certain distance, say 200 km or 300 km. If you increase the speed, the time taken to complete the duration or to complete the journey will be reduced. More speed, less time. Less speed, more time. So here again you can see the speed of the car and the time taken to complete a certain journey. These two quantities, they are in inverse proportion. Clear? So if x and y are two quantities such that when x increase then y decreases and when x decreases, y increases, then the two quantities are in inverse proportion. Okay, clear? Now, suppose x and y are in inverse proportion, and in two different situations, say in a particular situation, the value of x is x1 and the value of y is y1. Then the value of x becomes x2 and the value of y becomes y2. I told you in case of direct proportion, when x and y they are in direct proportion, then x1 upon y1 is equal to x2 upon y2. But here, when they are in inverse proportion, as x and y are in inverse proportion, x and y are in inverse proportion, then x1 into y1 is equal to x2 into y2. So always remember, when they are in inverse proportion, then x1 into y1 is equal to x2 into y2. Clear? In case of direct proportion, it was x1 upon y1 is equal to x2 upon y2, but here it is x1 into y1 is equal to x2 into y2. Clear? Now we will do few examples based on this inverse proportion. Six pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of the same type are used? Now see, here the two quantities that are in consideration is number of pipes and the time taken to fill a tank. Now the quantity of the capacity of the tank is fixed. If you use more pipes, so it will take less time. If you use less pipes, then it will take more time. That means the number of pipes used and the time taken to fill the tank, they are in inverse proportion. So you write as the number of pipes used and time taken to fill the tank are in inverse proportion So, first of all, you make a table. Number of pipes used X. time taken while now see, when 6 pipes are used, the time taken is 1 hour and 20 minutes. 1 hour means 60 minutes. So 60 plus 20 is 80 minutes. You write down 80 minutes here. And then when 5 pipes are used, time taken is y1, you can see. Clear? And now as I have already mentioned that they are in inverse proportion. So 6 into 80 will be equal to 5 into y1. That means y1 is equal to 6 into 80 upon 5. Okay? Sixty into 6, 96 minutes. That is 1 hour 36 minutes. That is your answer. That means instead of 6 pipes, if we use 5 pipes, then the time taken will be 1 hour and 36 minutes instead of 1 hour and 20 minutes. The time taken will be 1 hour and 36 minutes. Clear? Now the next question. Next question. There are 100 students in a hostel. Food provision for them is for 20 days. How long will these provisions last if 25 more students join the group? So now you see the two quantities that are in consideration over here is the number of students in a hostel and the number of days for which the food will last. Then obviously if more number of students are there and there is a limited supply of food, then the food will last for less number of days. If less number of students are there, then the food will last for more number of days. So you see, when one quantity is reduced, the other increases, or when one quantity is increased, the other reduces. So they are in inverse proportion. Clear? So you write as the number of students in a hostel and the number of days for which the food will last are in inverse proportion. So now we'll make the table. number of students number of days. Now initially 100 students were there and the food was sufficient for 20 days. It is given. So when it is 100, then it is 20. Now what happened? They are saying 25 if more students join the group. Now there will be total number of students 125. So when 125 students are there, then this is y1. Now you have to find this y1. That means for how many days the food will last. So as I have already mentioned that they are in inverse proportion. So 100 into 20 is equal to 125 into y1. So y1 will be equal to 100 into 20 upon 125. So you cancel it by 25. 25 4s are 100, 25 5s are 125. And 5 4s are 20, 4 4s are 16. So the answer is 16 days. Okay. So when more number of students are there, the food will last only for 16 days instead of 20 days. It will last for 16 days. Clear? Now the next question. Next question. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours. Now you see here the two quantities that we have to understand. One is number of workers employed for a work, and the second is the time taken to complete that work. I have already told you that when more people, more workers, more laborers are employed, then the work will be finished in less number of days. And when less number of workers are there, so the work will be finished in more number of days. That means they are in inverse proportion. So as number of workers and the number of hours taken are in inverse proportion. So now make a table. Number of workers, that is X. Number of hours, that is Y. When 15 workers are there, the time taken to complete the work was 48 hours. Now we have to complete the work in 30 hours. So they are saying how many workers are needed. So now you have to find X1. How many workers are needed to complete the work in 30 days. Now you see, I have already mentioned that they are in inverse proportion. So 15 into 48 is equal to X1 into 30. So X1 will be equal to 15 into 48 upon 30. 15 to the 30, 24. So 24 workers is your answer. Okay. Using 15 workers, the work is completed in 48 hours. If you want to complete the work in 30 hours, you need 24 workers. There should be 24 workers in all. Clear? Next question. Next question. If a box of sweets is divided among 24 children, they will get 5 sweets each. How many would each get? How many would each get if the number of children is reduced by 4? Is reduced by 4. Now you see, here the two quantities are the number of children among which that the box of sweets is distributed and the number of sweets that every child is getting. So very simple thing, you have a box of sweet, that means the number of sweets are fixed. So if more number of children are there, so each child will get less number of sweets. But if less children are there, each child will get more number of sweets. So the two quantities are in inverse proportion. So as number of children and the number of sweets each child gets, are in inverse proportion. So we'll make the table. Number of children number of sweets each one is getting. So now you see, initially the number of children 24 and each one was getting 5. Now the number of children is reduced by 4. Now it is 20. So you have to find how many sweets each child will get. So now, as I have already explained, that these two quantities are in inverse proportion. So 24 into 5 is equal to 20 into y1. So y1 is equal to 24 into 5 upon 20. 6 is the answer. Means now each child will get 6 sweets. Each child will get 6 sweets. Clear? Okay, that is your answer. Now the next question. Next question. A farmer has enough food to feed 20 animals in his cattle for 6 days. How long would the food last if there were 10 more animals? If there were 10 more animals. Now see here, the two quantities are the number of animals and the days for which the food is going to last, if the food is fixed. So if a fixed amount of food is there, if you increase the number of animals, then the number of days will be reduced. Similarly, if you reduce the number of animals, the number of days will increase. So they are in inverse proportion. So we'll write as the number of animals and the number of days for which the food will last are in inverse proportion. So make a table. Number of animals number of days now when there are 20 animals, then the food was sufficient for 6 days, and now 10 more animals are there, means 30 animals. Then you have to check for how long the food will last. So I have already mentioned that the two quantities are in inverse proportion, so you will write 20 into 6 is equal to 30 into y1. So y1 will be equal to 20 into 6 upon 30. So we can cancel these two zeros. 4 days is the answer. Means if 10 more animals are there, then the food will last for 4 days instead of 6 days. So it is quite obvious, when more animals are there, the food will be consumed more with more speed, and it will last for less number of days. Clear? Now we'll do the next question. Next question. A contractor estimates that 3 persons could rewire Jasminder's house in 4 days. If he uses 4 persons, how long should they take to complete the job? Now see here the two quantities, the number of persons employed for a certain task and the number of days taken to finish that task. So obviously if you employ more number of people, it will take less number of days. If you employ less number of people, it will take more number of days. So they are in inverse proportion. So you will write as the number of persons employed and the time taken are in inverse proportion. So number of persons X, time taken Y. Now you see, when 3 persons are employed, the time taken was 4 days. Now he employed 4 persons, so you have to find this Y1, that is the time taken to complete the work. I have already mentioned that these two quantities are in inverse proportion, so you will write 3 into 4 is equal to 4 into Y1. So Y1 is equal to 3 into 4 upon 4, that is 3 days. So you can see when 3 persons were employed, the work was finished in 4 days, and now when 4 persons are employed, the work is finished in 3 days. When more persons are there, if you go on increasing the number of persons, the time will be reduced further. Clear? Because they are in inverse proportion. So whenever you face a question, here in the previous class we did almost all the examples with direct proportion. Today we did almost all the questions with inverse proportion. But in your exam, when the question comes, you have to decide whether these two quantities in the question, they are in direct proportion or in inverse proportion. Accordingly, you have to apply the formula. So in the next period, we will do few mixed questions in which both direct proportion or inverse proportion questions will be jumbled up. So we have to decide whether here the two quantities, they are in inverse proportion or they are in direct proportion. Clear? By reading the question, you have to ask the question to yourself: when the first quantity is increasing, then the other quantity is increasing or decreasing. If your answer is increasing, then it is in the direct proportion. If your answer is decreasing, then that means the two quantities are in inverse proportion. Okay? So in the next class, we will do few mixed examples. Okay?